Project Management, Chapter 6. In Chapter 6, we look at developing the project network. So the project network is a flow chart that shows the activities and the logical sequence of those activities through a project from completion to start. The critical path is the longest part of that project. This project network helps us have the basis for scheduling any resources that are used. It tells us when an activity is going to be completed or needs to be completed before the next one can be done in the project, different things that could hold the project up. It gives us a basis for cash flows. The identities are critical, are those things that if they are delayed in any reason, will delay the entire project. So these are the things that get deemed critical. Other things can be done late and the project could still be completed on time. The project network helps us stay on plan. So we go from the WBS and work packages to our network. So we have this example from a previous chapter where we have a circuit board, we have design, production, test systems, and software. So we have the different organization units and what they're assigned to do for it. Then we have different components of that work network. So our activity network for circuit board work packages are that we need to start with the design and specifications. We can't move forward to create a prototype until we have the design and specifications from the design department. So the design department is the very first thing in the network. It tells us how long each one of those takes. So that we have it could mean 2 weeks to complete that. Once we have design and specifications, we can create the first prototype and we would have preliminary software. Then we move into a final prototype, final software, and finally the test. So the test is going to happen last after we have all of the other components done. In a network, activities need to be completed in a specific order, and we're told what the timing of those activities are. So when we're looking at a project network, we need to know what our activities are. The activities are the components that require time but may not require resources. A merge activity is an activity that has 2 or more preceding activities on which it depends. It means that something else in our network has to be completed in order for us to start on our activity. Parallel activities can occur at the same time or independently. When we're looking at this network construction, we have our path, which is the sequence of activities. So we have activities A, B, C, and D. A must be completed before B can be completed, but C is an independent activity. We have that A and B and C can have different lengths and time to complete activities. The critical path is the longest path through the activity network that allows for the completion of all project-related activities. This is the shortest expected time in which the entire project can be completed. Any delays along the critical path will delay the completion of the entire project. When we have a burst activity, this is an activity that has more than one activity immediately following it. So example, we have A, B, C, and D can't be completed until A is. So A is a burst activity. We have 2 approaches for connecting those activities. We have activity on node, or AON, which uses a node to depict an activity. Those are our square boxes, or activity on arrow, which uses an arrow to depict our activity. The basic rules that we need to follow in developing project networks are that our networks typically flow from left to right, from first activity to future activity. An activity cannot begin until all preceding connected activities are complete. Arrows indicate flow. They can cross over each other. Each activity must have its unique identity. So whatever our sequencing system is or our labeling system. An activity identification number must be greater than that of any of its predecessor activities. So we wouldn't say DCDA, we would go ABCD. Looping is not allowed, which means we're not allowed to go back and create arrows that have us repeat activities. Conditional statements are also not allowed. Conditional statements are if this happens, then this. So in our project network, we need to have absolutes. We go from step A to step B to step D, C to step D. And there is no if C works one way, we go to E, and if C works the other way, we go to D. That's a conditional statement that would not be allowed. When we're looking at the activity or the AON fundamentals, which is what this chapter focuses on, we see that we have these different examples. So in the first example, A is preceded by nothing, B is preceded by A, and C is preceded by B. So they must be developed in sequence, and A must be done first, B second, C next. In the second example, we have Y and Z are preceded by X, but Y and Z can begin at the same time. They can happen simultaneously if we so desire. When we're looking at this next example, we can do J, K, and L all at the same time. They do not have to occur simultaneously, but we can be working on them simultaneously. But all three of them must be completed before M can start. So that makes that a merge activity. In the last one, we have that Z needs X and Y to be done, and AA needs X and Y to be done. So in this example, we have a list of activities and then what the preceding activity is. So for example, we see that there's no preceding activity for A. So A would be the beginning of our activity. Then we can work on B and C. So we can assign the team and design hardware once A is complete. So A feeds to both B and C. When we use this information to draw a network, we start here. We have A, define requirements, and then we draw to B and C. Then from B and C, we would move to D, which can be done after B is finished, and E and F, which can be done after C is finished. So we see this full system. This is our full complete network. So we've drawn from A through H all of the activities, and we've connected which activities must be done preceding before we can move on to the next activity. The next part in the process for this would be assigning how much time it takes to complete each activity. So we would ask ourselves, how soon can the activity start? How soon can the activity finish? And how soon could the entire project finish? When we're looking at forward pass, when we're looking at a forward pass, we look at the sequence or the chain of events through the network to the last project activity. As you go along the path, you add the activity time. The longest path shows the project completion time for the plan and is called the critical path. For backward paths, it's the latest times that these things could be completed and still get through. Which activities are a critical path? How long could our activity be delayed? We're going to talk about slack or float later. So we go back to this example. We drew our original thing. Now we have time. So A takes 10 days, B takes 5 days, C is 25 days, and we go through our entire project. And how many days does it take us to complete steps A through H? When we're looking at forward paths, then we have what are the earliest dates? Well, if A takes 10 days, the earliest day we can start B is after 10 days. That's our early start. Okay. Our duration, you can see this legend down here in the corner. The duration for B is 5 days. So we have the early finish is 15 days, 10 days for A and 5 days for B. So we're saying the earliest we could finish this would be 15 days. And we move through each project to calculate what are those times that we suggest this project is going to be finished. So when we're doing a forward pass, we add all these activity times. We carry the early finish to the next activity where it becomes the early start. Unless if the succeeding activity is a merge activity, then the largest early finish number of all its immediate predecessor activities is selected. So we go back here and we can see that we have activities that all flow into H. So we have 70 days for G to be finished, 85 days for E to be finished, and 50 for F to be finished. So the early start on H is the longest of those, 85. So this is when we're looking at the backward pass, then we have our duration, our late start, and our late finish. So if we have a duration of 10 days, our late finish is 10 days. However, here we have 25 days and 10 days. So 25 days is for C and 10 days is for A. So it only takes us 5 days to complete B, but because we can't start the next steps in the process without C getting done also, we have some flexibility in how fast B gets done then. So with our backward pass computation, we're going to subtract activity times along each path, starting with the project end activity, or our late finish minus the duration, or equals our late start. If we have a succeeding activity as a burst activity, then our smallest late start number is the number of its successor activities selected. And we're going to do some examples. I'm going to post an example video where we walk through these calculations. So now we have forward and backward passes completed with slack time. So we have the earliest start for H is 85 days. The earliest finish is 100 days. That gives us 0 slack time for the end project. But here we can see that where we talked about, because C takes 25 days and B takes 5 days, that gives us some slack time before we have to complete B and still finish the project on time. Oh my God. like going to screen.